Hi, this is the commercial phase range detector system that we're using the DSP microchip starter kit and a speaker and microphone to emit a sine wave signal and receive it, and then the system will calculate the phase, and then from the phase we'll find the distance and show it on the three LEDs on the board in the binary form. I was the team leader, and for the first part, I was part of the team to write the phase function code, and then after we finished, we helped other teams to finalize the code. And also in the second part, I was testing the code, the board, to see if it's working, and then we can implement the rest of the codes on it. So and after that, I did some algorithm check, so everything is we work on the correct method basically. And also after that, I started to help the other teams to write the codes to like the FFD and the main function, basically. I mean, mainly to finalize the code. And then all of us, we worked on the testing and debugging using the software. Done. In this part, I'm going to explain the code. This is the main function open here. On the top here, this is the delay function that we made. Then when you go down, these are some of the values that we defined, like the ADC handle and the PWM handle. Then it comes to the main function. We turn the LEDs off in the beginning to make sure that there is no error, and then comes to the initializations. We initialize the ADC and PWM generator, and then start both of them. And then after that, this is the sine generator, and it will play that basically from the PWM. And then we'll stop the PWM, receive the ADC. After receiving the ADC, we will pass the audio that we received to the FFT function, and then the output of that goes to the phase function, which is here. In the phase function, we're going through the whole receive file and finding the maximum value, taking here we're finding the absolute value of each element, and then when we find the maximum, we will take the arctangle of that value that would be the phase, and we'll return it to here. Here we will get the absolute value of the phase and show it on LEDs. And when we go down at the end, this will to change the phase to the distance, as we calibrated the system, and we found out that the system works between 0 to 15 centimeters. So the 180 degree phase will be 15 centimeters. So each therefore each reading needs to be divided to 12 to get the distance. And this is the watch window, which we're going to use to debug the code. Okay, in this part we're going to test the board, and we will play the sine wave and then receive it, and then we show on the three LEDs the distance. And as we can see here, so we play the board. That was the sound. This is showing the full range basically, because the distance here is on 13 and a half, for example. And as you can see here, this is the angle 167 degree, and this is the distance, which is 13.9. So it will be really accurate measurements. And because that's today, because we're showing the 15 centimeter on 3 bits binary, so it will be on the last one, which is 7. Thank you.